right, so this is our last video, and this is part 2 of the most recent packet I gave you for graphing trig functions that had a video with it. So this is practice with probability. We're going to start with counting problems, then we're going to do some combinations, permutations, and then we're going to do some probability. Okay, so number 17. How many different 6-character license plates are possible that start with an E, followed by 2 digits that cannot repeat, followed by 3 letters that can repeat? Okay, so 6 digits. So we're going to put 6 slots. It has a start with an E, and then 2 digits, and then 3 letters. So, there's only one option for the first slot, and then followed by 2 digits that can't repeat. So there's 10 options for the first digit, and then 9 for the second, since we can't repeat, followed by 3 letters that can repeat. Okay, so there's 26 options for each of the 3 letters. So what we want to do is we want to multiply all those numbers out. So 1 times 10 times 9 times 26 times 26 times 26. Oh, I did plus. 1 times 10 times 9. 26 times 26 times 26. That's better. 1581840. Okay? Alright, so I want you to pause and try number 18. And you should be getting 31,200,000. Okay, so now we're going to talk about combinations, permutations. Number 19 says, in how many different ways can a class of 16 be divided into groups of 3? So we have a total number of 16. We want to split it into groups of 3. So remember, with combinations, the order doesn't matter, and with permutations, the order does matter. So we're just separating into groups of 3. We're not ordering the people who are in those groups. We're not saying one of them has to be the president and one has to be the vice president, or one has to sit in seat number A, one has to sit in seat number B, stuff like that. Okay, so that means this is a combination. N is 16, R is 3. Okay, you want to do 16, NCR 3. So, 16. Math. Go over to probability. So you can push the left arrow once. And then NCR is right here. And 3. 560. Okay. Number 20. How many ways can a president, vice president, and secretary be chosen from a group of 25 members? So, N is 25. And R is 3, president, vice president, secretary. But there's a specific ordering for those 3 people. So that means we're going to use permutations here. So that's NPR 25, NPR 3. Calculator. We'll go 25, math, go over to probability, NPR 3. 13,800. All right. In number 21, how many different arrangements of the letters of the word envelope are there? So, arrangement means the ordering matters, okay? This is one of those problems where one element shows up more than once in the group. Okay, so the letter E, for example, shows up more than once. So this is a distinguishable permutation. So what we need first is N. by counting 1, 2, 3, 4, 5, 6, 7, 8. There's 8 characters. Okay, and then we say how many E's are there? 1, 2, 3. 3 E's. There's 1 N. There's 1 V. 1 L. 1 O. And 1 P. Okay, and so then if you look at the formula on your formula sheet, we do n factorial, so 8 factorial, over all of these factorial. Remember though, 1 factorial is just 1. So we really don't have to put all those 1 factorials in there. We can, we'll get the same answer. So we're going to go to our calculators. And 8. Then you go math, probability, and there's your factorial right there, number 4. Divided by. Just get into a good habit of putting parentheses for your denominator, because sometimes you're going to have more than 1 element down here. So divided by 3 factorial, 6,720. Okay, so I'd like you to pause, and I want you to do numbers 22, 23, and 24 on the back. Okay? There's 1 combination, 1 permutation, and 1 distinguishable permutation. Alright, so 22 ends up being a permutation because we're ordering first, second, and third. And you should get 117,600. Number 23, this is a combination. And you should get 3,876. Number 24, this is the distinguishable permutation. We're ordering things, and the elements are showing up more than one time. There's multiple reds, multiple purples, and so on. Okay? So you end up doing 11 factorial over 5 factorial, 3 factorial, 2 factorial, 1 factorial, which you don't have to write. And that comes out 27,720. Okay. So now we're going to move on to probability. Number 25, you choose 1 card from a deck. What is the probability that is an ace or a diamond? So, there's 4 aces out of 52. Or, plus, there's 13 diamonds out of 52. So this is 17 out of 52. The only thing we have to be careful of here is that there is an ace that is a diamond. So there's 1 overlap. So we have to account for that. So we're going to take out 1 out of 52. Because one of these is both an ace and a diamond. So we're double counting. So the probability that's either an ace or a diamond is 16 out of 52. Okay, try 26. It's similar. And the probability that we have a club is 13 out of 52. The probability that it's a 10, 4 out of 52. But again, you could have the 10 of clubs, so you want to take 1 away. So you get 16 out of 52. Alright. 27. 2 cards are drawn from a deck. That changes our sample space. Sample space is all the groups of 2 that we could choose from the deck of 52. What is the probability they are both 5s or both 8s? Okay, so our sample space, I'm going to call SS, is 52 NCR2. Okay, there's 52 cards in the deck. We want to know all the groups of 2. Order doesn't matter. 52 NCR2. Our sample space is 1326. Alright, so both 5s, or you think plus both 8s. So for 5s, there's 4 5s. And how many groups of 2 can we take from those 4? 4 NCR 2. You get 6. Or both 8s. So it's the same for 8. There's 4 8s. You want to choose 2. That's going to come out to 6. Now the or means plus. So 6 plus 6 over 1326. Which is 12 over 1326. And don't worry about simplifying that fraction. Okay, number 28. 4 cards are drawn from the deck. What is the probability that 1 is a king and 3 are 7s? So our sample space, all the groups of 4, we can choose from those 52 cards, so 52 NCR 4. So 270,725. Okay, now, what is the probability that 1 is a king? Okay, so there's 4 kings. And we want to choose 1. So 4 NCR 1, you get 4. And 3 are 7s. So there's 4 7s. We want to choose 3 of them. So 4 NCR 3. It's 4 again. This word and, think multiply. So 4 times 4 out of our sample space gives us 16 out of 270,725. Okay, number 29. 3 cards are drawn from a deck, one after the other. What is the probability that the first is a jack, the second is a king, and the third is another jack? The one after the other in succession. Okay, so the first one is a jack. That's 4 out of 52. Times the second is a king. 4 out of 51 because we took the jack out. And then the third is another jack. Well, we already took a jack out. So now there's 3 jacks left out of the 50 cards that are left. We want to multiply straight across. 4 times 3. 48 over 52 times 51 times 50, 132,600. Okay, so I'd like you to pause now and try the last 3 problems, 30, 31, and 32. All 3 problems, you're going to use this information up here. Okay, number 30, you should get 60 out of 1,140. Number 31, 30 out of 15,504. And 32, you should get 640 out of 116,280. Okay.